This is section 2.1a, quadratic functions. And so chapter 2, like chapter 1, talks about functions, and this is very important for calculus because calculus is all about functions. Calculus deals with rate of change, especially, of functions, and also the area underneath the curve of functions, derivatives and integrals. So functions are very important if you are preparing to take calculus next year. Even if you're not preparing to take calculus next year, functions are still important for real-life math, and if you take any kind of math in college, good knowledge of functions is important. Okay, so we're going to talk today about quadratic functions. Let a, b, and c be real numbers such that a is not equal to 0. The function f of x equals ax squared plus bx plus c is called a quadratic function. Okay, I'm sure you knew that already, but just bear with me as I go through some basics, because this chapter, especially chapter 2, does get difficult rather quickly, and so it's important for you to, even though you know the stuff already, write it down, review it, because every time you review something, you learn it just a little bit better. The graph of a quadratic function is a parabola, and we saw this also in chapter 10. Ax squared plus bx plus c is simply a polynomial, and we know that we can also put it into standard form, but we'll get to that in just a bit. So every parabola is symmetrical about a line called the axis of symmetry. And so we have our axis. Sometimes you'll see the axis just labeled axis, sometimes it'll be labeled axis of symmetry. But it's the line that bisects the graph. And so, of course, it bisects it into two equal parts, and we could say that the graph is symmetrical about that line or that axis. You can think of that axis as a mirror, or you can think of that axis as the crease along which you fold the paper in order to get the two parts of the graph to line up. The intersection point of the parabola and the axis is called the vertex of the parabola. You can also think of the vertex as the lowest or highest point of a parabola. And again, we did see that in chapter 10, so this is a bit of a review. The leading coefficient of ax squared plus bx plus c is a. All we mean by leading coefficient is the coefficient of the variable with the highest power. Okay, so since our variable here is x and its highest power here is squared, power of 2, well then the leading coefficient is a, because a is the constant in front of x squared. Okay, so that's what we mean by leading coefficient. For example, if I had the polynomial 4x cubed minus 5x plus 2, just a random polynomial, right? The leading coefficient would be 4. Alright, so the leading coefficient of ax squared plus bx plus c is a. When the leading coefficient is positive, the parabola opens upward, and the vertex is a minimum. So when you look at the sign of a, the sign of your leading coefficient tells you whether it's opening upward or downward. So when the leading coefficient is negative, the parabola opens downward, and the vertex is a maximum. Alright, so in both cases, we have here written ax squared plus bx plus c. Now this a may be positive, it may be negative, and that's going to determine whether the parabola opens upward or downward. Now you might remember that from when we were doing reflections in chapter 1. You take a negative of the whole function to get a reflection in the x-axis, and the effect is it flips the whole thing over. The simplest quadratic functions are of the form f of x equals ax squared, a not equal to 0. All right, if we look at we're gonna look at these graphs here in a bit. Their graphs closely resemble the graph of y equals x squared. So remember that y equals x squared is the parent quadratic function. The parent quadratic function. Remember that from chapter 1. So compare the graphs of y equals x squared, f of x equals 1/2 x squared, and g of x equals 2x squared. And you could probably sketch these on your own, because this is a good review of vertical stretching and vertical shrinking. So pause the video, sketch those on your own, all in the same pair of axes, and then resume when you have an answer. So this is the graph of y equals x squared, and then the graphs of 1/2 x squared and 2x squared appear here as well. The graph of 2x squared is the same thing as, or you could call it, a vertical stretching of y equals x squared. The graph of 1/2 x squared is a vertical shrinking of y equals x squared. And we call it vertical shrinking. Again, we said this in chapter 1, but we call it vertical shrinking because we're like making it shorter and fatter, so to speak. I know that a lot of students tend to think of vertical shrinking more like horizontal stretching, because that's kind of what it looks more like. But just remember that vertical stretching makes your graph taller and thinner. Vertical shrinking makes your graph shorter and fatter. Graph f of x equals x minus 3 squared plus 2. Find the vertex and axis. Alright, you'll recognize that this is already in standard form. And so you should, based on what you know from chapter 10, you should be able to do this. So I'd like you to pause the video and try it on your own. But you know, don't worry if you get stuck or you're a little rusty on the chapter 10 stuff. You can just resume if you need some help. Okay, so f of x equals x minus 3 squared plus 2 is the same shape as the graph of g of x equals x squared, but shifted upwards 2 units and right 3 units. And we know that from our knowledge that we gained in chapter 1 of horizontal and vertical shifts. Okay, remember that when the constant is within the parentheses, horizontal shift, and negative is right, positive is left. When the constant is outside of the function, then it's a vertical shift. Okay, so that's nothing new. And then we can simply sketch the graph. We know that y equals x squared looks like that. Well, then we can simply graph x minus 3 squared plus 2 by shifting that 3 units to the right and 2 units up. And we have our vertex 3, 2, because this function, this quadratic function, is already in standard form of x minus h squared plus k. And that's the standard form of parabolas, right? X minus h squared plus k. And so we have the h of 3 and the k of 2, and those are the coordinates of our vertex. Okay, so basically everything on this screen is really just a review of what we saw in chapters 10 and 1. The standard form for the equation of quadratic functions f of x equals a times x minus h squared plus k. The graph is a parabola opening upward if a is greater than 0 and downward if a is less than 0. The axis is x equals h. You see that x equals h is just a vertical line. So the axis is x equals h, and the vertex is hk. Graph the parabola f of x equals 2x squared plus 4x minus 1 and find the axis and vertex. Alright, so I'm going to walk you through this example, and then I'm going to give you another example that you can do on your own. Now we need to find the axis and vertex, and when you see something, a quadratic function that's written like this, just as a normal polynomial, well, your first thought should be that you need to convert to standard form. So we're going to transform 2x squared plus 4x minus 1 into its corresponding standard form equation. So we have the original equation, and then now we're going to complete the square. So f of x equals 2 times x squared plus 2x minus 1. We're just factoring out the 2. And now we complete the square because, x squared plus 2x here, we have to add half of that middle term. And half of that middle term is 1, so we're adding 1. But notice that it's 1 times the 2 that was factored out. So effectively what we've done is we've added 2 And to make up for that, we subtract 2. We added 2 here, so we subtract 2 there, and the net effect is just adding 0. And you know, when you add 0 to something, you don't change it at all. All right, so we're going to continue completing the square. And we're left with 2 times quantity x plus 1 squared minus 3. We now have a standard form of this quadratic equation. And therefore, we can graph, and we can graph with the vertex at -1, -3. And we know that the vertex is -1, -3 because we have our h and k. This is in standard form. And so if x minus h here is in parentheses, that's the same as x minus -1. Therefore, our h is -1. The plus k here is -3, so k is -3. And therefore, the vertex, the coordinates of the vertex are -1, -3. And the axis, or the vertical line which bisects the parabola, is the vertical line x equals -1. All right, so the key to this example is completing the square in order to get it standard form, because once you have standard form, then you can just do a quick sketch from it. It's pretty easy to do a quick sketch from it. Graph and find the vertex axis and x-intercepts of f of x equals -x squared plus 6x plus 7. Okay, so you now you know enough to do this problem on your own. Some of it draws a tiny bit on chapter 1, finding x-intercepts, but you also learned that in algebra 2. So pause the video, do this completely on your own, and then resume when you are finished with that. F of x equals -x squared plus 6x plus 7. We write the original equation because we're going to now transform this into standard form. Factor out the -1. Complete the square. Notice that we added 9 here because the half of -6 is -3. -3 squared is 9, and that's why we add 9. And notice that since we factored out the negative, then this is equivalent to subtracting 9. And to make up for subtracting 9, we add 9 over here. We add 9 over here. And the net effect is 0. So we're left with the standard form equation of negative quantity x minus 3 squared plus 16. Since a is less than 0, the parabola opens downward. And we can sketch this easily because we have our vertex of 3, 16. We have our axis of x equals 3. And finally, we need to find the x-intercepts, and you know that to find x-intercepts, also known as zeros, you set the function equal to 0. And that's because your y-coordinate is going to be 0. So when you factor and solve, you get the zeros, or x-intercepts, of 7 and -1, and therefore the coordinates of the x-intercepts are -1, 0 and 7, 0. Find an equation for the parabola with vertex 2, -1 passing through the point 0, 1. All right, you also should be able to do this on your own. So pause the video, try it, and resume if you get stuck or when you have the final answer. F of x equals a times x minus h squared plus k. That's the standard form. We are now going to fill in what we know. So we put in our h and k since we're given the vertex. And we know that 0, 1 is a point of the parabola. The parabola passes through 0, 1, and therefore the coordinate 0, 1 must satisfy the equation. And so all we're doing here is we're plugging in the coordinates. Do you see how f of x over here is just f0 because we're plugging in the x coordinate is 0, and then we plug it in over here, and then we know that we can put the minus 1 down here, and therefore 1 equals 4a minus 1. Now, how did we go from f of 0 equals 1? Because we know that if I plug in 0 as my x-coordinate, then my y-coordinate is 1. And since the y-coordinate is the same as f of x, that's why this f of 0 becomes 1 down here. And then all they did here is they just evaluated, because 2 squared is 4, and so you have 4a minus 1. And solving for a, we get an a of 1/2. Therefore, we have now solved for a, and we can write it out this way. F of x equals 1/2 times x minus 2 squared minus 1. That's standard form. Okay, so basically this is given in two ways here. This first part, okay, this first way of writing f of x is writing it in standard form. And that's just, we're plugging in the a that we found, and the h and the k that we were given. But then the next thing they do is, and you don't necessarily have to do this, but the next thing they do is they write the same function, but now they write it as a regular polynomial. And how did they go from f of x equals 1/2 x minus 2 squared minus 1 to 1/2 x squared minus 2x plus 1? All they did was they simply multiplied this out. They just multiplied this out, and when you multiply that out, you are left with 1/2 x squared minus 2x plus 1. These are interchangeable. Okay, these two are interchangeable. They are different ways of writing the same function. They're simply different ways of writing the same function. The classwork, page 134, please write these numbers down and we'll work on them in class.